Healthcare is changing, and Dr. Nancy RN is here for you. The topics are many, but each program stands on its own with 3 key action points for you to learn. Your guide to a healthier you in a changing world. Dr. Nancy RN.
Welcome to Dr. Nancy RN, Healthy World, Healthy Nation, Healthy You. I'm Nancy Valentine, PhD and registered nurse, and this show is dedicated to you, the healthcare consumer. And today we are going to be talking about a topic that most people have some interest in, or they know someone that they could help. After listening to this show, you will be very versed in sleep and what influences sleep. So the title of our show today is Respecting Grandfather Time, Sleep, Biological Rhythms, and the Elderly in particular. The science of a good night's sleep. Now, why is this important? We're going to be talking about how you have biological rhythms, part of your whole body and your whole chemistry, and how these rhythms really influence how you sleep or how you don't sleep. And we are going to be talking about tips, what you can do to change your environment so that you don't either have to take sleeping pills at night to go to sleep, or you don't have to be taking stimulants like caffeine in the morning just to get going. Because with the tips that we're going to be talking about today, you will be empowered with this new information to make changes in your patterns and in your environment that will help you. And the person that's going to be helping us today is a renowned person in the field of chronobiology, and I'll explain that in a minute. Let me introduce our guest today, Dr. Donald McEachran, PhD. He is a teaching professor and coordinator for academic assessment and quality improvement in the School of Biomedical Engineering, Science and Health Systems at Drexel University. And I want to thank Don for being with us today, because when we've talked in many of our other shows that it takes a village to really help us with our own health care, we tend to think of people more with the backgrounds of doctors or nurses, etc. But we really are expanding this village, because as a neurobiologist and as a chronobiologist, you bring a whole other science and your engineering background to the table that really is going to help us understand this in a new way. So Don is going to be very good at taking something that at first glance could be extremely technical, and he's going to boil it down and make it very understandable. Now, let me just introduce one thing that Don did. He wrote a book on chronobiology engineering, and it's a really wonderful book, even though it's highly technical for the average reader. But in going through even the table of contents, what he has done in this book is he has taken these rhythms, these biological rhythms, and he has been able to map it to all kinds of different illnesses and diseases, and be able to demonstrate that with this knowledge you can actually make some very profound changes in the treatment regime of these disorders such as heart disease, cancer, and others. And we're maybe going to have some shows on that, Don. So I really am excited about this whole new entity of time, and how time really influences our biology and our whole well-being. So maybe we could start, Don, with time as a concept and how you got interested in time.
Well, I actually started my interest with a much broader concept of time, looking at evolutionary biology. That was my interest, and it broadened to animal behavior. And one of the things that has been known with animals for quite some time is that their behavior changes, of course, be a time of day. There are some animals that are active at night, some animals that are active in the day, some animals that are active even at the light to dark transition. And this is part of this idea that your whole behavior and your whole physiology is organized around time of day. And the story I give to my students is the story of the early bird gets the worm. And we all know that cliche, but it's not quite accurate, because the problem is, how early is early enough? If you're a bird and you're arriving at the feeding grounds trying to find your share of worms, what happens if you arrive too early? Well, if you arrive too early, the worms are not available, it's dark outside, it's cold, there are nocturnal predators, foxes, cats, that might eat you. And so it's not that you get there early, it's that you get there on time. And for the past 2.5 billion years, in fact, for the entire 4.5 billion year existence of the planet, but certainly for the time that life has been available, all living organisms have been subjected to this extremely powerful selection pressure, where you have an alternation of light and dark. And all of our physiology and our biochemistry and our behavior has evolved to meet this continuing cycle.
Okay. Wow. So that's fascinating. A person that's really sort of chronically late, I really have to really pay attention to my own biological rhythms and that early bird gets the worm idea. I love that to get going. But in terms of your interest, how did you harness your interest in time to all these various biological applications?
Well, this began when I was a graduate student at the University of California in San Diego, and I worked with a psychiatrist at the time, Dr. Daniel Kripke. And Dr. Kripke was himself a chronobiologist, but also a psychiatrist. And he was looking at affective disorders.
Okay.
And there is evidence that has been growing over the years that one of the either causal or contributing factors, things that influence affective disorders, things like depression and manic depression, are biological rhythms. So he introduced me to the concept, and I began working with animals at that time, looking at the impact of agents such as lithium on animal rhythms.
I see. That's fascinating. I think that one of the things that really helps us to understand this application of this information is that often things like this are considered brand new ideas. They're not necessarily brand new. It just takes a long time for these ideas to get adopted by the so-called mainstream, either mainstream media or even mainstream medical care. And that's part of why we're bringing it directly to you, because some of these things are really pretty simple when you really get down to it, but if you don't know, you don't know what to do. So let's take the idea of sleep and these rhythms, since that's the topic of our program today. Especially as people get older, you pointed out that there are some changes in the body, just part of aging, that also influence these biological rhythms. Maybe you could walk us through that.
Okay. Well, these are almost two overlapping topics, sleep and biological rhythms. Sleep is a necessary activity that all mammals certainly have to engage in. Experiments where they have looked at animals such as rats, if you deprive them of sleep long enough, they perish. They cannot live without sleep. So sleep in and of itself generates positive effects on the body. Biological rhythms, the ones we talk about typically, for example, the daily rhythms, the idea of circadian rhythms, the things that run at about 24 hours. Circadian rhythms position sleep so that it occurs in the right part of the light-dark cycle. So between the two things, the need for sleep and the rhythms that control when you sleep, as long as those two things are working in concert properly, you get the right amount of sleep at the right time so that your body is refreshed and renewed and functions correctly. This affects both your mood and your physiology.
Okay. But when that gets disrupted, or as you age, what happens?
Well, if we take a look at this hopefully simple diagram, what you can see is that there's an environmental cycle, which is the light-dark cycle, that links to and synchronizes a biological clock. There's a clock embedded in the brain that actually runs at approximately 24 hours, about 24 and a half or so. It's then linked to the light-dark cycle and synchronized so that you end up with a biological cycle that matches the light-dark cycle. This clock then synchronizes a whole set of clocks within the body. Seems very overly complex, but evolution sometimes gives you complex results. At any rate, in order for the whole system to work, the light-dark cycle has to accurately entrain or synchronize the biological clock, and that master biological clock has to synchronize a set of secondary clocks.
And where do these secondary clocks reside?
All over the body. There's secondary clocks in the liver, in the adrenals, apparently in the heart. So you have multiple clocks, all of which are linked to this master pacemaker or clock, which is then synchronized by the light-dark cycle.
Right. So this clock really doesn't exist in any one place in the body. It's just sort of, or does
Well,
it?
the master clock does.
Where does it reside?
It exists in an area of the brain. If I were to actually push my fingers in like this, you'd meet that area of the brain. I won't do that. But it's an area of the brain called the hypothalamus.
Okay.
And it's an area which is involved in what physicians like to call homeostasis, homeostatic activities. And part of the homeostatic activity is the timing.
Okay. So that master clock in your brain does control other cycle implications in other organs and parts of your body.
Yes, that's correct.
So does this master clock work flawlessly, or does, when the master clock gets disrupted in some way, which you really have to tell us what those influences are, then I guess all the smaller clocks, they go haywire too.
Perfect. That's absolutely correct. When this system works properly, it's like an orchestra. All right, you have a symphony that sounds beautiful. But many of you have arrived before the orchestra begins, and you know all the individual instruments when they're tuning up. It sounds like noise. It really is noise. If the system isn't functioning, you have kind of temporal noise, bad timing in the body. So if you think about this, if your light-dark cycle is synchronizing this master clock, and you start shifting the light-dark cycle around, for example, you go to the West Coast, all right, you go across several time zones. Well, now your external time and your internal time don't match. And it takes a little while for the external time to sort of resynchronize the internal time. Now, this is like a cascade. First, you have to get the master pacemaker resynchronized to the light-dark cycle, and then the master pacemaker has to resynchronize these other clocks, and then you begin to have the symphony work again. So when you travel, you get this thing called jet lag. And jet lag is this temporary noise. It is the orchestra trying to get itself back together again, get the conductor back, everybody on the same time. Jet lag can be severe. But imagine, for example, if the clock itself, if the conductor was somehow off sync. If a conductor of the orchestra was actually conducting the way I'm moving my hands around, and all of a sudden the trombones are playing with one tune and the trumpets are playing with another and the flutes are playing with another, you go back to noise. One of the things that seems to happen with mammals is that this area, this master pacemaker in the hypothalamus, deteriorates as you age. So it is less powerful. It doesn't conduct as well on its own. And it becomes more and more dependent on a powerful light-dark cycle to synchronize it to maintain the symphony.
That's very interesting. So just understanding that and trying to visualize what that is doing inside your body, what kinds of things really get in the way of people doing that as they get older? Is it that they have to pay more attention to the time clock, the night-day cycle, than they would ordinarily? What are the kinds of things that people can do to compensate for that reality?
Well, as the internal clock becomes less powerful, it's important that the external clock become more stable so that your exposure to light and dark become more predictable. So one way of improving your ability to sleep, for example, would be to use red light at night rather than white or blue light. Turns out the clock in your brain is less sensitive to red light than it is to blue light because the part of the eye that senses the light is different for the two things. So one way of improving this would be to have less light at night. If you can't go to absolute darkness, and that's very hard in the city.
Right.
Or it may be that you need to get up at night sometimes for various reasons. And you want to have a night light there. If it's red, it has minimal effect on the circadian system and is less likely to disrupt your sleep.
So just to translate that, it means that it keeps you in that subdued state.
Yes.
That rested state. So you're not like, the lights went on. And
Right.
then that sort of like hits your clock and sets it off. Because some
Right.
people can seem to go back to sleep right away when they get up and put the light on at night, but many people can't. That alone sort of jolts them back into more of a wakeful state.
Right. It actually is, the system has evolved to do just that. It's part of how light-dark synchronizes your clocks. But if you expose yourself to light at the wrong time, the clock tries to resynchronize to a new cycle that you don't want it to do.
Right. So what I hear you saying is that by having this red light, you're really supporting the natural rhythm of
Yes.
the body. And that's where we're sort of taking the science and putting it together with daily activity so that a person would have more control over their sleeping successfully than if they just put lights on like they used to do.
Yes.
Right.
And getting outside in the morning and being exposed to sunlight early in the morning, that's an excellent way of helping the system adjust as well. The other thing is to try and keep as regular a schedule as you possibly can. There's a trick. You know you're keeping your schedule properly if you wake up just before your alarm goes off. If you are waking up multiple times at night, this is a problem. If you are sleeping to the point where the alarm has to wake you up, that's a problem. So keep a regular schedule, minimize your exposure to light at night, and if you have to be exposed to light at night, try and make it as red shifted as possible, a red light. Expose yourself to light during the day of high intensity. And also, there are certain tricks with in promoting sleep, such as making sure that the bedroom really is designed for sleep. This is sometimes hard for people like students who are in dorm rooms. But if you minimize the number of other activities that occur in your bedroom outside of sleep, you don't work on you don't have a computer system set up there, you don't watch lots of television there, that actually tends to promote a sense that when you get into the bedroom, the purpose of being there is to go to sleep, and that actually helps.
Right, so that's a behavioral prompt
Right.
as well. Let's go back to, you made a point that when you wake up, you do just the opposite. You purposefully expose yourself to some kind of light, either outdoor light, but if it's not sunny out on a particular day, what do you suggest? Put bright lights on?
Well, you can put bright lights on. There are certain types of alarm clocks that use light to wake you up. They're called dawn simulators. I'm not fully convinced that the commercial versions of dawn simulators are sufficiently effective. But certainly, the more light you can expose yourself to earlier in the morning when you get up, the better off you're going to be. But again, it's a matter of maintaining the schedule as much as possible. For example, we often have this odd schedule where we work 9 to 5, as if anybody works 9 to 5 anymore, but we have a working schedule Monday through Friday. Friday night, we stay up a little late because we know we can sleep late on Saturday. The problem with this is that as you sleep later on Saturday, you then go to sleep later Saturday night. Then you sleep even later on Sunday, go to sleep later on Sunday night, and suddenly get jerked back into the work schedule on Monday. You actually have to shift back, and that puts an enormous strain on your body.
That's really interesting. Do you think that there are lots of differences among people with this? I mean, not everybody is the same. So are there some people that are really very, very sensitive to this and other people that are less sensitive? And if so, what are the factors that influence that?
Well, there are a number of factors. Yes, there's a great deal of individual variation. There are two types of individuals, sometimes called larks and night owls. People who, and this encompasses an estimated 20% or so of the human population, where you have people who are more active at night because it's natural for them to be more active at night. They seem to peak in their activity more toward the 8, 9, 10 range. Then you have larks who are much more active in the morning. I can't for the life of me, understand that myself. I'm not a lark, but these individuals become more active earlier. They're much more productive earlier in the morning. The problem from the point of view of these types of individuals is this: our society doesn't recognize that we're all shoved into the same cycle.
Right.
So they are going to be, a lark would be less productive in the afternoon and early evening than the average individual. The night owl is going to be less productive in the morning than the average individual. And if we would just take that into account, they would they would be actually more productive overall.
Right, right. So I think that what I hear you recommending to us is that if you're a lark, you compensate one way. If you're an owl, you compensate the other. But even with all those variations that may exist, getting that environment set up so that your environment of sleep is very conducive to doing that. You set up all the behavioral cues. Then you try to sleep at the same hour of night as frequently and as consistently as possible.
Yes.
Because that will help. Then the next thing you told us was in the morning, make sure you have light stimulation through your eyes, seeing outside, going outside, putting a lamp on in the kitchen, whatever, so that you're telling your biological clock that you're awake now and it's time to get moving. This may sound, for a lot of our folks listening, that it's like way too scientific. In our culture, it seems that we have been conditioned just to the opposite. It's easier to take a sleeping pill and be done with it than to go through all of this. But what would be your recommendation to people who may want to get off of some of that medication, or they may not want to start that medication to begin with? Because when you really think about it, I'm sitting here thinking as I'm listening to you, we have so many ads on TV about sleeping. Sleep disorders, take a pill, or take this medication or that medication, which again is direct to consumer, really trying to appeal to people that if they have this problem, this would be a solution. The other ads that you see are mattresses. You know, everybody's selling mattresses and they're all discounted. Or if you're in the high end of the socioeconomic scale and don't care how much you spend for a mattress, you can be spending thousands and thousands of dollars for the top of the line mattress. All of which is with the promise of sleep, that really holy grail, as you pointed out earlier, of our entire biology, that we must sleep in order to have good health. So do you think if people took some of these steps that they could sleep on a regular mattress that was, decent enough, that they wouldn't have to be drinking so much coffee to wake up during the day, and they wouldn't have to be taking sleeping pills at night, all of which are, at least 2 out of the 3, are really changing your biology in some way by taking a substance, a chemical. You're really trying to deal with this chemically rather than environmentally or more naturally with these sleep patterns. I don't know if you consult with people that have sleep problems or you talk to people, but what's your opinion of all that?
Well, it's a complicated issue. Sleep disorders come in various forms, and not all sleep disorders can be easily solved simply by changing the environment. But I think in urban society, because of our 24/7 approach to life, and because we haven't recognized our biological clocks, our need to be synchronized, our need to have a regular schedule, that we make the problem worse. I think certainly a subset of the population could reduce and possibly eliminate, but certainly reduce their need for stimulants and for sleeping pills if they were keeping a regular schedule and assuming they slept sufficiently. It's two things. There's keeping the regular schedule. That's certainly important to keep your rhythms in sync, to get the symphony playing properly. But you also need a certain amount of sleep. There was a recent study that looked at, and this is looking behind, it's by survey, so you don't know, it's not as scientific as I would like to see these things,
right.
But by survey it still is information, that seemed to indicate that people who slept much less than 7 or 8 hours, or much more than 7 or 8 hours, had a reduced life expectancy, that there was actually a long-term result associated with that non-normal or abnormal sleep pattern.
That is pretty powerful. I don't think most people recognize that. They may think that they just have a sleep problem, or they're going to take a med, or they're going to get a better mattress, whatever, or pillows. That's another biggie. Get the right pillow. But it really is very serious with that kind of data, that people that have sleep problems don't live as long. That's a pretty powerful statement, because it's not like you have a disease necessarily or an illness. You don't have cancer. You don't have necessarily heart disease. These things may be related to your sleep problems. That's a whole other discussion. But just sleep in and of itself is that basic to survival.
Yes. One of the things that there's certain endocrine factors associated with the way you sleep.
Tell us what that means.
For example, there's a hormone called growth hormone. And the name kind of gives you a sense of what it does. But growth hormone stimulates your immune system. It stimulates tissue repair. So it helps you recover from the wear and tear of the day. And what's really interesting is that this hormone comes out and is pulsed. There's a significant secretion when you go into a certain stage of sleep. If you don't go into that stage of sleep, you do not get that pulse of growth hormone, period. So if you stay up 24 hours, you're a student and you're pulling off an all-nighter, for example, to study for a final, which is a bad idea for a lot of reasons, that loss of sleep permanently removes that pulse of growth hormone. So in fact, you've worn a little more than you should have. Your immune system is a little less active than it should be. So when you miss sleep, it costs you incrementally. And there's only so much you can recover. You do recover a certain amount, but you don't recover at all.
Right. I think that what we've learned today is just, again, to have incredible respect for our bodies. And in the spirit of self-care, which is really a major theme in many of our shows, and that is, how can you take better care of yourself? So that, in the case of sleep, you will live longer, and you will also have a better quality of life day in and day out. I mean, that's an understatement, because people that can't sleep and have sleep disorders are really very miserable. It really is something that gets in the way of daily living in a very significant way.
I think that if you believe you have a sleep disorder, for example, I have something called sleep apnea. So I stop breathing periodically when I sleep, more than usual. Everybody stops breathing a little bit, but this is quite a bit. So I would recommend that if you feel you have an actual sleep disorder, you should go and have it checked out at a sleep clinic.
Right. I think that what we're trying to do is we're trying to say today, for starting out, we have some tips for you, especially if you're older or if you're taking care of someone who's older. And let me just review what we went through today in our discussion. We talked about the main biological clock, which Don told us is in the mid part of our brains, which becomes less stable as humans age. So it's just something that comes with our aging process. The fact that our eyes change too, and they become less sensitive to certain kinds of light, means that we have to compensate for that in order to really synchronize these light and dark cycles, which he showed you on the graphic. And that he also gave you a tip that lighting in your environment can be designed so that it is less disruptive to your sleep at night if indeed you have to get up. So that's where the red light comes in as your night light rather than regular light. I think that Don also gave us a lot of other environmental tips that have to do with how to stage your room and to be sure that it's comfortable, that it really has a lot less stimulation. You're not doing a lot of other activities in that room. Sleep is the main theme of your bedroom. So this, I think, is a beginning to, again, a really fascinating field that I think Dr. McEachron is going to come back and do some other programs with us in terms of these biological cycles, this chronobiology. And he, as an engineer, is bringing a lot of information to the table. He and his colleagues across the country are really going to help us refine medical care and nursing care in terms of how we are going to deal with people in the future more effectively. So I really want to thank Don again for being with us. I think it's a fascinating field, something that most of us really have not been exposed to, and I think as we learn more, it just makes a lot of sense. It really does, and it's a great place to start with your sleep problems. So I hope that you've learned something today that you can use or you can pass on to your friends and family. Remember, with health, all things are possible. Thank you for joining us. Have a wonderful day. I hope you enjoyed our conversation today and that the information will help you in meeting your health goals. Catch this program and other conversations on the website, drnancyrn.com. Or you can write to me as well. I welcome your comments and feedback. Thank you for listening and join us again. And remember, with health, all things are possible.